I think recording now. All right, so basically what's going on with this is we're talking about relative, and it's versus absolute. That's what the key here is. And you need to know this because in calculus it becomes really important. But for right now, this is the easiest thing you're going to do. If you're looking at a graph, and this is based on a graph, when they talk about relative or local, it's basically in the general vicinity, is there a change in direction? If something goes up and comes back down, is that a relative max? Think about it. Goes up and comes down. If something goes up and comes down, up on one side, down on another, is that a relative max? Doesn't matter what it does outside of it, but in that general vicinity, is that a maximum? If it's a minimum, did it go down and then go up? So if you're reading from left to right, if it goes down and comes up, it's a minimum. If it goes up and then comes down, it's a maximum. And it doesn't matter what's going on way away, but in this general vicinity, if it goes down and comes up, that's a local or relative min. If it is out here, it's a local, it goes up and then comes down, it's a local or relative max. And why do I say that? Because I might have a graph like this, where it does this, right? And if it does something like that, if we go to points, like right here, just in this general vicinity, did it go up and then go down right here? So what is that point? It's a relative maximum. Is it the absolute maximum? No, because is there a higher point? So this is a relative max. Local means the same thing. Some people say local, some people relative. Why I like relative is because I can abbreviate it. REL. Local is 5 letters. Takes too long to write. But does local mean the same thing as relative? Locally. Locally means really close, right, to where you are. Now, what it's going to have is this is going to have an endpoint, and this is going to be an endpoint like this. So if you're looking at all of the points between those two endpoints, is there an absolutely the maximum point and an absolutely minimum point?
Yeah.
Yeah. Is this the absolute minimum? Is this the absolute maximum? Got it? A relative minimum cannot be at one of those endpoints. Why? Because I don't have a change in direction, do I? So that what I'll tell you right here is they cannot, absolute mins and absolute maxes can't be at the beginning or the end, or where it's constant, which means it's flat. So if I have a function like this, suppose I have a function like this that goes la la la, woo, la, like that, has an endpoint here and an endpoint here. This flat part is not a relative min or a max. Do you see that? Even if it does this, that's not a relative max. It has to be a point. Is that a point? No, it's a line segment. Do you see what I'm getting at? This is not a relative max. This is not a relative min or max. What about this point right here? This one. What is this one?
That's a relative min.
Yep, that's a relative min. What's this one? Relative max. What's this one? Relative min. Is this easy? Yeah, that's what I need from you. The whole point here is, and the key point, because when you get to calculus, you will use this, and it has to be taught again. You'll look in the general vicinity, right around the point. Just to the left of the point, if it goes up, and just to the right of it, if it goes down, it's a relative max. If just to the left of it, it goes down, and just to the right of it, it goes up, it has to be a min. And they're relative. And then you look big picture. What's the highest point? What's the lowest point? And what they'll do is they'll give you an interval. If it's a closed interval, meaning, the brackets, the points are included, you're guaranteed, as long as it's continuous, as long as I didn't pick my pencil up, are you guaranteed